Our theme in this unit is the learning of mathematics, and we are busy at this moment with deciding how to talk about the relevant phenomena, that is, how to use the central words such as learning and mathematics. In the last module, we made our decisions about the word learning. Endowed with the operational definition, we are now ready to tackle the question of how to talk about mathematics. This is what I will now be doing in this module. Let me begin by recalling our definition of learning introduced in the last module after I declared that I would follow the participationist strand. The definition I've chosen is this: learning is the process of changing our patterned ways of doing things. These patterns are what changes when we learn. Most valued in our society is the type of learning that brings our individual ways of acting closer to what is done by people who are more experienced than we are in attaining desired outcomes. Thus, the most valued patterns are those that developed throughout history and are now prevalent in a society. These historically established recurrent ways of acting will now be called activities. Among these activities that evolved throughout generations before reaching their present form, and which are now learned by almost any society member, are, you name it, cooking, dressing, talking, exercising, drawing, and many, many more. To summarize, in this unit, we are interested in learning, through which the learner becomes a participant of a historically developed activity. Schools are institutions created specially to promote this type of learning. The question that needs to be asked now is, what is the historically developed activity in which we try to participate when we learn mathematics? To find an answer, I started searching libraries and the web. Here is what I found. Mathematics was described there as mirror of reality, as mirror of truth, as science of patterns, as describer of universe, as a hypothetical system, as an aspect of culture, a language, and as a logical system. These descriptions are just a small but representative part of all I found. Yet look at them closely, please, and you cannot but notice that they do not speak about activity. Indeed, look at this: universe, mirror, language, aspect of culture, system. None of those is activity, not even one of them. Instead of processes, they all mention static constructs. So can we really think of mathematics as an activity? And if so, what kind of activity would it be? You may say that mathematics is a type of research. Indeed, just like biology is the activity of doing research on living organisms, such as plants and animals, and as physics is the activity of doing research on material objects, so is mathematics the activity of doing research on mathematical objects. So if you know what research is, then you can also know what mathematics is. But can we say that what research is in terms sufficiently clear so that defining mathematics as research becomes useful in research? Can we do this? First, while trying to say what research is, we need to remember that research is always about something. It has a special focus. Here, the X stands for a noun that specifies the object of research, and this object can be anything. It can be physical object, as it is in physics. It can be living organism, as it is in biology. It can be past events, as it is in history, and it can be a mathematical object, as it is in mathematics. And here is my definition of research. Research on X. Research on X is the activity of building a theory of X. But clearly, defining is a recursive process. And having said this, I need to answer the question of what a theory is. What is this thing called theory? Okay, so my definition of theory may go like this. Theory of X is a potentially useful story about X. But then, sorry folks, yet another semantic conundrum. What is story? At this point, even those of you who have been looking forgivingly and my relentless defining may think that I overdid it this time. First, story is really a word that even babies seem to be familiar with. Second, what can such a frivolous thing as a story have to do with such a serious thing as theory? But please look closer. Here are 3 examples of research outcomes. So, in psychology, you can tell a story. One's childhood experiences have considerable impact on her future life. In mathematics, you may say the sum of angles in a triangle equals 180 degrees. In physics, you say S equals half gt squared. Aren't all these stories? Even the one in physics, as unlikely as it may seem at the first glance as an example of a story, does turn into a narrative once we decode it and write it in words rather than symbols. So we may say the distance traveled by a free-falling object is equal to half of its constant acceleration multiplied by the square of the time of the travel. Of course, these 3 propositions you are seeing here are not full stories. They are just tips of icebergs, the rest of which can be found in academic journals and books. So here comes my definition of a story. The term story about X, where X is a noun, is used as referring to a coherent sequence of utterances that, when taken together, can be said to be about X or on X or of X. The aboutness means that X is the grammatical object of some of the utterances in the sequence, and the sequence in its entirety is consistent and cohesive. Now, the term consistent says that there is no contradiction, no logical conflict between the utterances. This term, cohesive, indicates the presence of lexicogrammatical links that hold the sequence together, that is, connect its successive utterances thematically. The connection may be chronological, as is the case when the successive utterances are linked with the words such as before, after, or next. It can be logical, attained by the use of connectors such as therefore, it follows, and, or. And it can be causal, expressing itself in the presence of words such as because. Most current uses of the term story or narrative imply chronological interconnection of the utterance of different parts, and thus our present definition leads to a wider understanding of this term than some of you may be used to. The last question that needs to be answered so that we can feel our definition is complete is about the term useful, which is often replaced with the word true. To explain, I need to say a few words about the role that stories fulfill in our lives. Since Aristotle, humans are often said to be born storytellers. Our propensity for stories has good reasons. Except for storytelling being our favorite pastime, stories fulfill two centrally important, indeed indispensable roles in our lives. First, they are our best tools for sense making. Indeed, to make sense of something means combining all you know into a single story about this something, into a sequence of utterances that are consistent and cohesive, exactly as stated in our definition of stories. Second, stories are our tool for deciding about how to act. You mediate your actions by stories when, for instance, during shopping for lunch, you base your decision about what to buy in what you know about the kinds of food that are good for you. And mathematical stories mediate your planning of a new house when you base your decisions on what you learned in school about geometric shapes. Scientific and mathematical theories are built precisely for this purpose. True, some people mediate their actions with theories that may not count as scientific in everybody's eyes, as is the case when one tries to cure herself from an illness with magic or charms. This only shows that the question of what stories count as useful is a complex one. It depends on storytellers' tastes and choices. The mention of usefulness as the required property of mathematical theories may evoke some doubt. Some mathematicians may share D.H. Hardy's conviction that their activities have nothing to do with anything useful. Yet the majority of mathematicians seem to be of one mind with Andrew Forsyth, who famously claimed that almost any mathematical story would eventually turn useful, provided we have the patience to wait for a problem that can be solved with its help. The last question that needs to be asked is what features a story must have to deserve the name theory? In other words, what is it that makes a story useful as a sense-making device and as a helpful mediator of our actions? Clearly, in natural sciences, a story, to count as a theory, must be unambiguous, consistent with experience, widely applicable, general, that is, must present patterns rather than specific cases, and this is only the beginning of a long list of requirements. In mathematics, on the other hand, at least in principle, consistency and cohesiveness are all that is needed to ensure that a story is seen as a theory. This said, mathematicians also strive to make their theories as complete as possible, believing that for every utterance about X, either this sentence or its negation should be a part of a theory of the theory of X. And how do we make sure that our stories have all these required features that are necessary if our stories are to count as theories? Well, this is done by telling the stories in a specially designed discourse. The word discourse, to be now operationally defined, is our storytelling tool. Here is my definition. Discourse is a form of communication, a communicational game that defines a community. Community of a given discourse consists of people who are able to participate in this discourse. This is exactly how it is with games. the community of, say, chess consists of people who are able to play chess. It is important to remember that discourse may be in words, but more often than not, it is multimodal. Sometimes it takes place just in sounds other than words, in body movements, gestures, facial expressions, pictures, any of these or all of them together. Discourse can be practiced with others or with oneself. In this later case, the discursive activity is called thinking. Here the next question arises. How can we tell one discourse from another? And the fact is that we can, and usually with ease. Indeed, imagine that you enter a school classroom. Nobody tells you what is being learned here, but after a short while, you do know whether you are in, say, mathematics classroom or in any other. How do you figure it out? The mathematical character of the conversation that is taking place in the classroom is signaled to you by a number of characteristics. The first and most obvious of them is the words you are hearing: numbers, number names, function names, derivative, and much more. But this is not enough. These words appear also in other discourses. But you are guided also by the characteristic visual mediators, that is, visual means with which we make clear what it is we are talking about. Further, there are the stories or narratives that in this classroom are endorsed as useful or as true, that is, are included in the mathematical theory that is being developed. Finally, there are the characteristic routines, certain constant patterns of doing things that you recognize as mathematical. Among them, there may be routines for reading mathematical notation and for operating on symbols, those for convincing, which is known here as proving, routines for explaining the use of mathematical keywords known as defining, etc. Okay, we are almost done for today. I began with the question of what mathematics is and must end with an answer. I said that mathematics is a type of research. Research on X, in turn, is a special discourse in which a theory of X is being developed. Now, to get the definition of mathematics, all we need to do is to replace X with mathematical objects, or MOs for short. So here it goes. Here and here and here and here and here. I also need to put the word mathematics instead of research on MOS. And here's what we get. Mathematics is a discourse in which one builds theories of mathematical objects. So it seems we are done with defining mathematics, but not quite yet. There's one outstanding question. What are these things called mathematical objects? Unfortunately, I need to keep you in suspense until the next module. See you there.